We will factor first, if possible. If this can factor, we would get negative 2x and x. And it could be a possibility that when you try to factor something, it doesn't factor. If you're ever wondering, does it factor or not, you could always use the quadratic formula just to check. In this case, if I do negative 2 there and plus 1 there, and we multiply it out, we get negative 2x squared minus plus 4x plus 1x is plus 5x and negative 2, so it does factor for us. Our non-permissible value, x can't equal 1, and since it doesn't cancel out, we have a vertical asymptote at x equals 1. This is the situation where the degree is larger in your numerator than the denominator. That will result in an oblique asymptote. And you find your oblique asymptote with either long division or synthetic division. If you can use synthetic division, it is nicer. In this case, we have negative 2 by negative 2 divided by x minus 1, so plus 1 out here. Bring down the negative 2, multiply, add, multiply, and add. So our oblique asymptote is at negative 2x plus 3. Plug in 0 for x to find your y-intercept. That is often easiest by going back to your original equation. You get negative 2 over negative 1. So we have 0, 2. Find your x-intercepts by looking at the factored form. And we had it factored here, so what would make it equal to 0? 2 and 1/2. So start by putting in your asymptotes. We have a vertical asymptote at x equals 1. We have an oblique asymptote at negative 2x plus 3. So we have to graph that line. We know that that line has a y-intercept of 3, a slope of negative 2, down 2 over 1, down 2 over 1. And there's our oblique asymptote. We can label all of our intercepts. We have a y-intercept at 0, 2, an x-intercept at 1/2, and at 2. And we have enough information to draw the graph towards the asymptote because we have a point in each section. Now, when we say we have a point in each section, only the vertical asymptote separates things into sections, not the oblique asymptote. So sometimes students say, oh, I don't have any point in this section down here in the right-hand corner. But we're only looking to the right of this. We have this point here, so we have enough to go up towards the asymptote in both directions. There is. Yes. Based on this, yes. And it has to, yeah, and it does make sense. It does make mathematical sense. So like this is not true. I'm going to show you a very common E error that happens, and there's an asymptote error that happens a lot in these graphs. And this is, students seem to be good at going towards the vertical asymptote, but sometimes with an oblique asymptote, I see this. Woo! And at the very end, they swoop away from the asymptote. So that in purple would be a half a mark deduction, because the idea of an asymptote is your graph is always getting closer to it. So if you get close to it like the purple one, and then swoop away, then you're not really showing the correct behavior at the asymptote. So just something to be careful with. We don't have to do any extra points on this one. And I'm going to give you some time to try number 5.